we're still waiting for people to log in. I'm just going to launch a quick poll I just put together, just asking if those of you who are attending have attended our last webinar, which was on lined products for new construction. Just so I can kind of get an idea of what areas I can focus more on and what I can kind of breeze over, because there are a couple of topics that we have that kind of overlap between the two presentations. So I see those are coming in. Thank you for responding. All right, we still have people coming in. Hopefully that poll is still on the screen for most of you, and those of you just now joining, just asking if you attended our previous webinar, as there are a couple of topics that overlap between the two presentations. Please feel free to answer that. I'm just going to close that here in a moment. Looks like most of you are attending for the first time, so thank you and welcome. And those of you who are attending again, we appreciate your interest and your time. So I'm going to go ahead and close that poll now. And it's time to jump into things. So again, welcome. Thank you for making time to attend our webinar today. This is the second in our series on lined products, which we plan on doing quarterly. So there will be another one coming up in the next few months. Keep an eye out for that. My name is Brandon Tremelling. I'm the Technical Resource Engineer for Geneva Pipe and Precast. And today I'm joined by Elena Mikolova, our lined concrete product manager. Do you want to say anything, Elena? You are muted.
Thank you. Doing this for the first time. I want to welcome everybody to the webinar. Thank you for your time that you're taking to learn about the products. I'll be here in the background, kind of monitoring Q&A section. If you have a question, you can either utilize the Q&A section, and we will read them either as we go, or we will address them at the end. You can also communicate with us through the chat.
Okay, awesome. Thanks for doing that, Elena. So yeah, any questions that come up, please feel free to post them. Elena will be here to answer those, and then if there's a question that's relevant to the whole group, we might discuss that at the end. So please feel free to post those as they pop into your mind. Before we really jump into things, I want to mention that at the end of this presentation, we will be posting a link in the chat for you to fill out a survey if you'd like to download a certificate for professional development hours, which you'll just fill out the survey, and at the end of the survey, there will be the link to download that. In a few days, we will also be sending out an email to those who registered for the webinar, which will have a link to the video that we're recording this webinar, so you can view it again or share it if there are others in your group that were not able to make it today. And yeah, without further ado, I think we're ready.
And I also wanted to add one more thing, Brandon, and for everybody, you're currently muted. If you have any questions at the end of the presentation, please raise your hand. There's an option to raise your hand, and we will unmute you, so you can, instead of typing, maybe you want to ask us in person through the voice. That will work too.
Okay, thank you. Yep. All right, so again, this is our webinar for rehabilitation solutions to combat corrosion in sanitary sewer systems. We are happy to be here, and I'm going to start off this presentation by just giving a quick overview about Geneva Pipe and Precast. So we are based out of Utah. We've got several locations throughout the state. We've been in business for over 67 years now, and we're recently merged and acquired by Northwest Pipe Company. The three facilities that we have are in Salt Lake City, in Orem, Utah, and one in southern Utah, down in the St. George area. Most of our background is in precast concrete, and so what we're talking about today is directly relevant to what we've been doing for decades, and we're really excited to bring these solutions to the market, to our industry. As I mentioned, we were recently acquired by Northwest Pipe. So we have locations all throughout the country, and I like to brag that we are technically an international company because if you look closely, one of those dots are just south of the border. So we're going fully worldwide with this thing. Our agenda that we want to talk about today is really, what is the cause for the corrosion that we typically see in precast or cast-in-place concrete infrastructure? How does this happen? How does it impact our market? We'll talk about a couple of problems that have occurred, major disasters that have happened in the last few years related to concrete corrosion. We'll talk about some existing rehab solutions that agencies typically turn to when they observe that problem. And then we'll talk about what we consider to be more permanent solutions that we'll be talking about a couple of case studies. And then at the end, we'd like to open it up for any questions or discussion. And we'll just go ahead and jump into it. So microbiologically influenced corrosion, or microbial induced corrosion as it's used interchangeably, or as I like to say, Mike, because both of those are quite a mouthful, is the leading cause of deterioration in concrete sewers. It's a natural process. It is not indicative of any flaws or miscalculations in concrete collections systems. It is a fully natural thing that occurs, but it happens very, very slowly. And because it happens so slowly, it can often go undetected. Even if it takes a matter of decades for Mike to attack and begin to corrode and deteriorate infrastructure, the lifespan of concrete is typically 100 years. So even if we get halfway through the lifespan before anything happens, it's still a major problem that needs to be remedied. The process whereby this happens is the microbes and organic matter inherent to wastewater. As they travel through the system, they react together, creating acids that, while in the aqueous state, in the wastewater, is not necessarily a problem, but through turbulence or heat or other factors, it can become airborne. And as it's airborne, it attacks that concrete, creating these expansive reactions, which in this previous photo here on the left, you can see, if you look closely, that there are these flakes. And so essentially, flake by flake, layer by layer, the concrete degrades, falls off, eventually reducing that wall thickness, attacking the reinforcing steel, and so on until you get critical failures. Now, I mentioned the factors that can exacerbate this problem are, the first one is heat. Now, we're based out of Utah, which, while many people around the country think of snow and great skiing, is absolutely a desert. And in the summertime, it gets very hot, as we are currently experiencing. So that's a major thing. Turbulence, so downstream from a lift station or a drop manhole or anywhere where your water velocity is changing dramatically, you can get these hydraulic jumps, for example, where that added turbulence is causing those acids to go airborne and attack the concrete. The next is long transit times. The longer the microbes have to break down that organic matter, the more acids they're going to produce. And finally, the wastewater makeup. So let's say you have a wastewater line that is merging in a manhole with a line from a residential area. Sometimes the various components in that wastewater can accelerate the reactions, accelerate that microbial activity, and exacerbate the problem even further. Now, the impacts of Mike are many. The first is pretty obvious: infrastructure reliability. If it's weakening our pipes, weakening our structures, obviously our system is at risk. The next are health and safety, which go hand in hand. if we are weakening our concrete pipes, for example, and the joints are being corroded, eventually you might see the situation where you're seeing exfiltration. Exfiltration is a major public health concern because if you have that wastewater flowing out into the soil, possibly even entering your drinking water source protection zones, for example, that's a major public health problem. The next is direct costs, which is pretty obvious. The replacement or rehabilitation um, of degraded infrastructure, and finally indirect costs, which would be like if you are seeing infiltration into your pipes and collection system, you will be treating all that additional inflow downstream. So there's a major problem, and in our industry, typically money talks. So my company, while recognizing as concrete precasters that there is this inherent weakness to concrete when it comes to sanitary sewer collections, we recognize that there is a problem and we wanted to be a part of the solution. So we decided to start digging into this and we wanted to find out how big of a problem it really was. So here on the screen, this is a quiz question, and this isn't like the poll I posted earlier. This is just think to yourself, how much do you think the US spends annually on the rehabilitation and replacement of sewer pipes? Now, keep that in mind. This is only pipes. So we're not talking about manholes. We're not talking about wet wells for lift stations or anything like that. So just kind of think to yourself, and I'll reveal the answer in a moment. But while trying to answer this question for ourselves, we did what any modern scholar, engineer, scientist would do, and we turned to Google. And so through Google, we went to Google Scholar and we decided to start looking up research papers and reports and studies from around the world. What we found was studies from China, from Germany, from Canada, many from the United States. Uh, One of the interesting things we found was LA County, which is the most populated county in the United States, found that approximately 10% of their sewer pipes are subject to significant corrosion. 10%. If any agency's sewer pipes are to the level of corrosion that needs replacement, let alone 10%, that's a significant cause of concern and a major cost for that agency. But to answer the question I posed, we found that the US alone spends about $14 billion per year, again, on the pipes to rehabilitate and replace that infrastructure. So if you aimed high, good for you. But that is an enormous number that we recognized. There must be solutions in the marketplace that we can be a part of to help resolve this problem. Here are some examples of Mike from failures that have happened around the country. So as you can see there's some pipe collapse, manhole collapse or degradation. And I don't know about you, but I don't want to trust my life with those manhole steps if I had to climb down in the manhole. But realistically, that's what our operators are doing. Every time that they need to descend into a manhole and there's the risk of deterioration and corrosion that has been weakening that structure, they're possibly risking their life trusting those manhole steps. So speaking of risk, I wanted to highlight a couple of these disasters that have happened, and truly disaster is the right word. So this first one is a pipe collapse and sanitary sewer overflow that happened in LA County. This was an 8.5 million gallon spill. It was a 48-inch reinforced concrete pipe, which collapsed as well as the manhole directly adjacent to it. And in the studies, trying to find out what was the cause of this collapse, they found that the leading cause was the corrosion of the sewer pipe, the sewer infrastructure, where some of those wall thicknesses had gone down to less than an inch. The impacts of this are pretty clear. There was a major sinkhole that formed, which caused overflow at that point, as well as upstream. There was the closure of a highway off-ramp, which happened directly where this occurred, which, like, let's say that they hadn't caught this in time and the sinkhole just kept going and people are taking that off-ramp. That's obviously incredibly dangerous. But those closures of that off-ramp and the intersection caused major disruption because they were closed for 3 months, then there were obvious public health concerns. Actually, all of that water, the 8.5 million gallons, flowed directly into the ocean. It resulted in the closure of 7 beaches, major public health concern, obviously. And then finally, where that flowed before it reached to the ocean, it was contaminating cars, the roads, sidewalks, and even they had to replace some of the vegetation and park strips and planters and things like that. So obviously, a major problem that simply was attributed to a natural process, which is Mike in these concrete sewers. Now, the overall result of this project was they identified, through the collapse and formation of a sinkhole, which isn't ideal, but they identified that there was a problem. And through that identification, they were able to look through the nearby system and found a much higher area that required that rehabilitation and replacement, which resulted in a total cost of $13 million. Now, some could say they got lucky actually, because the reactive costs for emergency repairs are anywhere from 20 to 50% more than proactive solutions and rehabilitation. Now, because only a small section collapsed, all of the rest of this work, as you can see on this map here, was technically proactive. However, it was the result of a pretty significant disaster. The next one I want to talk about, and I'm just going to cover this one really briefly, is the Jackson, Mississippi disaster. And I should probably say the ongoing disaster of Jackson, Mississippi, because this is a very ongoing problem. Jackson, Mississippi is constantly having sanitary sewer overflows from collapsed pipe, from failed pump stations, from essentially just deterioration of their system. Which is, and when I say constant, I mean constant. Here's a table of just these sanitary sewer overflows for a few months of 2022. And if you're looking at that, those are all in millions of gallons, 7, 12 to 9 million gallons throughout that list. It's a major, major concern. And overall, through studies, they found that just Jackson, Mississippi had more than 520 million gallons of sanitary sewer overflows directly into the Pearl River. And after years of trying to resolve this problem, they still released 216 million gallons. Now, the overall cause of this is because the city of Jackson allowed their system to get to the point where they started to see failures. And because they weren't being proactive and rather they were being reactive, they were getting really behind themselves in terms of what they could afford to resolve. And so nowadays it's almost too big to handle. With all the reactive work they're trying to do, they can't be proactive. So it's a major solution, a major testament to why being proactive in our for taking care of our infrastructure is so, so important. Now, finally, I just want to touch on a local example here to Utah. Now, a while ago, I was giving a presentation pretty similar to this one to a group of wastewater operators, collection system operators in Utah. And I got to the end of the presentation. I was telling them about Mike and the concerns. And I said, so have you guys seen Mike in your system? And they all just kind of shook their heads and said, nope. And I said, really? How much of your system is concrete pipe, concrete infrastructure? And they said, oh, about 80%. And I said, really? You haven't seen any of it? That's kind of incredible. Good for you. And then finally, someone at the back of the room kind of rose their hand and said, well, maybe I've seen something like what you're describing. And I said, oh yeah, like where is it? And they said, right there. And they pointed out the window to a manhole that was about 100 feet away. It was actually on their wastewater treatment plant property. And it was the main manhole for their inflowing line into the plant. So we walked over there, and realistically, we didn't even need to pop open that lid because the layer of rust from the lid that had just fallen onto the ground from the corrosive gases and elements was enough to tell me what I needed. But we popped open the lid, and I don't know about you guys, but concrete's not meant to curl like that. And so we just looked down in this manhole, we took a look at it, and I just looked at them and said, so you've never seen it in your system, huh? Jokingly, but the reality is if our operators and if our workers are not looking for this problem, and if they're not trained to identify it when they see it, this is one of the reasons why it can go so unnoticed and why it can get to those critical failures. Because at first glance, somebody might think, oh, there's cobwebs there. But realistically, that is a major concern. And like I said, that's the main line coming into their treatment plant. If that were to fail, if that pipe were to collapse, if the manhole were to collapse, the overflows would be enormous, and the problem would be pretty catastrophic. It would be enormous problem with a catastrophic result. So, because there are such risks with this problem, there have been historic solutions and there are some common approaches. We're going to kind of go through the pros and cons of these, and I'm going to go pretty quickly because I think most people in our industry are somewhat familiar with these, especially if you're attending a webinar on rehab solutions. So we'll go pretty quickly. The first I want to talk about is our polymer coatings and sealants. So there are definitely pros of these. When you're using a new manhole, typically you're spraying those on, they can perform pretty well. They're designed to protect. There are a number of solutions for pipes, for relining pipes, for manholes and vaults, not so many. So this is a good one to resolve that problem. It can be adjusted, it can be checked for imperfections, it can be reworked if necessary. The downsides are that for rehab, it is not a great approach. I've talked to a lot of sewer agencies who have used various lining, spray liners, geopolymers. And while the lifespan of some of these are marketed to be 50 years, I've yet to see an agency that has seen them last more than 12 or 15. And an interesting note about that 50-year lifespan, this technology has not existed for 50 years. So it can be a major problem with some pretty major failures that just exacerbate problems in the long run. The next one I want to talk about are cementitious liners. The benefits of these are actually they're really inexpensive. They're very easy to install. You can make them however you want them. You can do it while your manhole's still wet after you clean it, which is all great. The downside is it's no better than the concrete you started with. It doesn't protect against mic, and actually, on some of these, they're known to have surface cracking as they dry. Just the rapidity of the drying process, you can get that surface cracking, which just allows that corrosion to just go through that coating and just continue its work. Definitely not even a solution. Not a solution at all, really. The final one I wanted to talk about of these was the cured in place manholes. Now, cured in place manholes are they can be very effective if the problem you're facing is I&I from just high groundwater. It can increase that flow capacity by reducing our coefficients of friction if you're going down into the channel. They can be spark tested, which means that we're checking for any micro perforations or penetrations that might have occurred during installation. And finally, they are somewhat customizable to different configurations, channels, benches, things like that. So they can be customizable. The downside is that this solution is considered to be very expensive. Now, when they do this, there are no mechanical fasteners used, which means that if any point delamination starts, it is going to continue, and it can, result in some pretty significant failures, resulting in either reduced flow capacity, clogging your system, even just developing the perforations that allow Mike to continue its work on the concrete behind is a problem. And finally, there was this quote that I took from a manufacturer's website, which said, in the case of industrial or chemical applications, warranty will be provided on a case-by-case basis, which suggests that there are applications where these liners are not suited for. So that being said, what I'm getting at essentially is there are not to date, there haven't been solutions that are directly they protect against that corrosion. They restore any structural integrity to the degraded structure, which is to say, if you're seeing the concrete degrade to the point where your wall thickness is reducing, maybe you're seeing some reinforcing steel exposed, none of these solutions actually restore that, except for cementitious grouting, which still is if you're already seeing the mic, you're just going to continue to see it. And finally, a solution that provides lifespan protection. Now, I mentioned both the spray liners as well as the cured in place manholes. They say that there is a lifespan of about 50 years. But as I mentioned at the beginning of this presentation, typically precast or cast in place concrete infrastructure is designed and intended to last for 100 years. So let's say you have a structure that's still relatively young in its lifespan. You put in a manhole 10 years ago and you're starting to see significant corrosion to the point that maybe you recognize, hey, we need to rehab this thing before it gets, too far. If you're looking at these solutions that I've talked about, you would be looking at rehabbing them multiple times within that structure's lifespan. In terms of the spray liner, you'd be looking at it, 4 or 5 times possibly. So the cost of that becomes pretty prohibitive when you're looking at just the entire life cycle cost of maintaining that structure. That being said, I want to use that to kind of pivot into what we consider to be permanent rehab options. So these options are, as I'm going to talk about them, we've got a couple that I want to cover, are intended to be full one and done solutions that both restore structural capacity that can be lost through the corrosion, that have entire full corrosion resistance, and will last for that lifespan, whether you're installing that manhole today and want to line it, or you're 75 years down the road and you just want to prolong it for the remaining life of that structure. So as a little bit of background to the materials we're going to talk about, I wanted to start off by talking about the technology that these are based off of. This material, as you can see here, that kind of goldish color, is fiberglass reinforced polymer. It's FRP. We use this as a liner material because it is proven. This material in use as a liner for concrete sewers was developed decades ago over in Germany. Over 2 million of liners made out of FRP have been installed over in Europe, and over 200,000 have been installed now in North America. My company, Geneva Pipe and Precast, is the only one that manufactures those, and they're all manufactured here in Orem, Utah, where I currently am hosting this webinar from. Now, the way that we do this is when we're talking about rehab, or if we're talking about lining a new structure, what we do is we'll take the configuration of whatever structure you have and we'll identify what the channels and dimensions and diameters and things of that nature are to be able to make an exact fit of this liner. We use anchors so that when we go to install that, it is actually grouted in and cast then monolithically to the structure. So it is inherently bound to the structure. And what we'll do is we have some molds that can fit pretty standard configurations. But let's say you have something kind of outside of the norm. We've got a CNC machine that we can custom make whatever structures are necessary. We'll spray it as a mold. We'll spray it with our FRP material, which, to be clear, is not at no point is sprayed on concrete. It is sprayed to essentially create a shell or a liner that we will then attach to your structure. So what's happening is we're taking that existing corroded structure, we are grouting a liner to it to add back that structure, to add a little bit more of that wall thickness to create that corrosion resistance. Now, when we're using this material, at least when we were looking at it initially, we wanted to see how it performed over time. So the photos you see here are cores that were taken from a manhole that was taken out of service after 20 years being in service. So these cores were sent to a third-party testing company where they identified what that liner thickness was, any evidence of abrasion, the condition of the concrete below, porosity, voids, things like that. What was found was that essentially the cores and the sample that was taken after 20 years of service was identical to the specifications that that same manhole was made with initially. So this material performs very well over time. And based on those results and other testing that has been done by others as well as ourselves internally, we feel very confident that this is the way to go for what we consider to be permanent solutions. As I said, numerous testing has been done. Just to quickly, very quickly, just run over this. These liners have been tested for chemical resistance, abrasion resistance, tear out strength, water pressure, jet resistance, sealing to the pipes. And the one I want to point out here is the crush test for concrete. Now, the benefit of this is that not only if we were to cast this into a new manhole or line a new pipe or something like that, this in no way affects the actual structural integrity, but what we're doing when we're rehabbing a solution is because we're adding grout back on, we are restoring that in addition to other steps, as I will discuss in a moment. So getting into the actual products themselves, the first I want to talk about is our hybrid PVC manholes. Now, these are a rather interesting solution to a problem where you need let's say you have a manhole that has been degraded to the point where you are concerned about the structural integrity. Sure, you could go in and maybe spray line it, do a cured in place manhole or something like that, but the actual structural integrity of what is behind that liner is in question. If you need something that is more structural and is going to last that lifespan, this is a solution that would be an excellent choice. Now, essentially what we're doing is we are taking that interior of that manhole and we will be fully lining it from the flow line up to the lid of the manhole, connecting that on, and we will be absolutely restoring the structural integrity of that manhole. The way that we do this, and I'm just going to kind of walk you through this momentarily, is we'll start with a degraded manhole. Now, this is an example of a project that was done some time ago. But typically when we're doing a rehab of any type, what we'll do is we'll start off by pressure washing the interior of that manhole. The purpose of this is to, first of all, clean it from all the microbial activity, any sort of waste, debris, just microfilms, things like that, but also to knock down any of that weakened material. Like I showed in that photo from the local example, the concrete appeared to be curling off of the walls. What's happening there is just even if we can't see them, there are micro fissures, micro failures in that concrete. So that high pressure wash will knock all of that debris down to make sure that we are working with clean, suitable concrete for us to adhere to. The next step, once that's done, is we will do a scan. We'll compare field drawings and things like that to identify what the configurations, what the pipes coming into that manhole, what the slopes, bench heights, all of that are for that particular manhole. And just as I showed earlier, we'll actually manufacture an FRP liner specific to that manhole. What we'll do next is we'll lower that in place and we will grout it to the structure. The process for this is all that needs to be done is we'll simply grind down the flow line in the channel a little bit. So once we set that liner in place, the flow line, the new flow line matches the previous existing flow line to prevent any additional turbulence, to prevent any sort of hangups or lips where debris or anything can, get caught in your system, and to prevent that turbulence from creating the airborne corrosive elements that I went over earlier. Once that's lowered in place and grouted, as you can see there, we'll add our mastic or butyl rope to on the joint where we will then lower down our PVC pipe. Now we use a large diameter C900 DR51 water pipe. The reasons for this are, first of all, DR51 on the diameters that we typically are using for this solution are pretty significant. They are actually structural themselves. So when we go to add this to the structure, we will grout the annular space between the existing structure and that PVC pipe, which not only restores the lost structural integrity, but actually exceeds the brand new structural integrity that that structure had when it was put into service. So we're taking what, let's say you had a standard 48-inch manhole, we're going to be adding the additional grout to get to that PVC pipe, and the PVC pipe as well will be adding structural integrity to your manhole. So you end up with that stronger structure than you had before. What we'll do next is we'll add more of that sealant to the top lip of that pipe. We will add a flat lid, a precast flat lid. If you can look closely, you can see that that also is lined. So as I said, the goal is to make sure that we have a fully lined system from the lid to the flow line, and ideally through your whole system, that at no point are we using exposed concrete to make sure that we're making the most out of our dollars for protecting our infrastructure. Once that's in place, and again, we use a flat lid typically. We'll replace a cone with a flat lid to ensure that we are uniformly loading that new structure, especially if we are removing a riser that, let's say, that has degraded to the point that we no longer can use that. We can actually still use the PVC up to where that riser was removed and beyond. The PVC pipe itself is so it has such structural capacity that it has passed the testing requirements for AASHTO loading, for HS20, HL93 loading. So let's say you had a manhole that was in the middle of a road. We could remove risers, we could remove the cone, and we could use just the PVC pipe if necessary to serve as the risers for that structure, and it would still perform well no matter what situation you're looking at. So it's a pretty interesting solution, no matter how degraded your risers and cone might be. Once that's in place, we will, like a standard manhole, use grade rings. We can manufacture what we call our telescoping collar or telescoping chimney, which essentially just protects those grade rings. That will just slide down in place. We'll then add our manhole lid and cover, and you end up with a fully lined interior. Now, here's a photo of the interior of that manhole once it is all cleaned up. As you can see, that PVC pipe just sits over that liner to really seal that off, and you end up with a clean, clear result of a fully lined and rehabilitated manhole. Now, the cool thing about this structure, actually, when they did this, to take it offline, to kick in that bypass pumping and plug it and do all this work, was only about 8 hours. So when we're doing rehab work, generally the bypass pumping is a pretty large portion of the cost of rehab. To be able to take something offline, do the rehab within 8 hours and kick it back on is pretty incredible, and can really dramatically reduce the impacts of, let's say it wasn't a road, your transportation, the disruption to local businesses, and just getting in and out of the road as a more safety concern for your crews is a major benefit. One thing that I really like to highlight, because it is directly relevant to the nature of this structure, is the fact that this product comes with a 50-year warranty. Again, warranty. We were talking about some of the other solutions and how they come with a 50-year lifespan. Now, 50-year warranty comes about because we are so confident in the performance of this material and this product, and we're specifically looking to create those permanent solutions that we're willing to put a 50-year warranty behind this product. And being the technical resource engineer, I am very pleased to say that out loud, to say that to you all, because that is what I consider to be one of the greatest attributes of this product. Personally, I used to be in city engineering and actually was a city engineer for a short amount of time. And to have a one and done solution, as I mentioned before, that I can put in place and be like, by the time I'm long gone, this thing will still be serving the system. That's a great benefit to our agencies, to our infrastructure, to our taxpayers, and to our overall infrastructure resiliency. Now, moving on, I wanted
Hey,
to.
Brandon, before you move on to out of the PVC manhole, we have a question from Julian Largo in the
Okay,
chat.
right. Do you want to answer that, or would you like me to?
You go ahead.
Okay, so I'm going to read this out loud for those of you that might be watching this later. We are recording this webinar, and we'll be able to you'll be able to view this later and share it to anyone who was not able to make it today. So this question is, how do you pre-treat the interior of a manhole that is constructed from brick or block? Do you have to replace the missing or damaged blocks or bricks and repoint the mortar before you install the liner? I fear that the water jetting used for cleaning would create more damage. Your thoughts? That's an excellent question. So typically what can be done is, for a standard precast manhole, we'll just do a high pressure wash. For brick manholes, that's more of a unique case, right? What we can do is we can use a high temperature wash, which will help with removing that the microfilms and just the debris and the material that you can get with your sanitary sewer manholes. You don't necessarily need to use that same amount of pressure because the corrosion potential, once you have filled in that annular space with that grout, goes down to zero. It can still impact any residual corrosion or corrosive elements. Once that is taken offline and we are pressure washing, what we're doing is we're cycling the air. We're getting that air exchange, and once that's out and we've used that hot water rinse, we've reduced the risk of additional corrosion to a negligible amount. Because once we've added back in that grout, even if there was, let's say, a few micrometers of corrosive elements in there, we've added so much more to the structure that we have still superseded, the original structural integrity. So that's an excellent question, Julian. And if you have any follow-up questions, feel free to post those in the chat as well. But that was an excellent one. And Elena, thank you for stopping because that's a great one to cover. So thank you both for that. I'm just going to jump back into it unless another question pops up. But one thing I wanted to highlight with these hybrid PVC manholes is we can actually do this without that FRP liner. So let's say that for some reason you were concerned about messing with the flow lines, or you could not do bypass pumping for some reason. There just wasn't an option for bypass pumping, but you want to line the interior of your manhole. What we can do is we can still use this approach, this technique. Now, what we'll do is we'll just clear off enough of that bench, and if necessary, we can add to the bench to make sure that there is a spot for us to seal against. We'll add our butyl rubber or mastic. We can lower in that same PVC pipe over down in your manhole. We can set it on that mastic. We will then grout up past that mastic to make sure that we are getting a full seal. So we're grouting directly to the PVC pipe. Now, one question that you might get, well, really quickly, we'll continue to construct the manhole the exact same way. We'll still do a flat lid and such, but I just wanted to pause for a moment and mention that when we do this, it would make sense for you to be concerned, like, well, I mean, if we're lining the whole manhole, but we're just using grout right here, what is the point? Like, why would I go through all this effort and still have grout exposed in my manhole? It's a good question. First of all, we can use some corrosion-resistant grouts for this in particular, but the real reason is because typically once these corrosive elements go airborne, they tend to rise. So you will usually see corrosion more severe at the top of a manhole. You very rarely will actually see it down on the bench area. So that's why in this case, it is an option for if you needed to not line the base for bypass pumping, or you were concerned with flow lines or things like that. This is an option as well. Again, we'll continue on the construction. We'll add our butyl rope or mastic to the top. We'll put on our flat lid. And again, we'll use our grade rings and telescoping chimney. But I like to focus on this slide for a moment. We actually supply corrosion-resistant manhole or grade rings. So if you did not want to use the FRP chimney, or if you did, we can use standard concrete grade rings. We can use our corrosion resistant. These are called Cretex grade rings. And there are options as well for going all the way up to the lid. The next product that I want to talk to you about is our FRP panels. Now, these are specific to large structures, large circular structures, large vault structures. And we're going to be talking specifically about a project where we implemented this. Now, this FRP panel material is the same material that we use for our manhole base liners. It's based off of that same technology. It's the same FRP material. It's got a couple other components in it that I'm going to show you in a minute with a cross section of the panel. But the benefits of this are that it can be customized to the internal dimensions of any structure. The photos that we're about to look at and the one on the screen right now is from a nearly 14,000 cubic foot lift station that was down in Bullhead City. What we were able to do was manufacture the FRP panels that match the exact inner dimensions of that structure, go in and line the entire interior of it, put it back on service, and essentially just create a brand new structure for all intents and purposes. The method that we do this is when we make these FRP panels, what we do is we bring them in, we will anchor them to your existing structure. This does require, again, some surface prep, and in this case, actually, there was significant corrosion where some additional concrete and rehab work had to be done prior to the lining. But because we have these panels that are already custom made, they are made to fit, we're able to come in, put this all in place, anchor it to the structure. As you can see on the left photo there, we'll come with a primary coat of an epoxy to seal all of those joints. We grout behind them, we continue on with the next level up and continue until we have an entirely lined structure. As you can see on those photos on the right, there's kind of a before and after. You can see that these are customizable to any fixture you have, any configurations or channeling you have in your structure. If you have submersible pumps that you want us to work around, it's fully customizable. And finally, in that bottom right photo, I like to point out that the hatches for this structure took up most of the lid. So where you see those beams going across, we were still able to line those as well, even as narrow as they were and as kind of in a difficult position as they were. The cool thing about this project in particular is that for being such an enormous lift station and the bypass pumping that would be necessary for a project such as this, the entire interior of this vault was lined within 2 days. So when we're talking about bypass pumping for a manhole, period, can be expensive. For a lift station of this structure or of this size, it can be incredibly expensive. So having a solution that not only comes in, lines the existing structure, restores structural integrity, and is considered permanent while being able to be installed so quickly is just all around, I think, an incredible product. What we did here, one of the cool things is that because it is so customizable and the panels are so small, they ship really easily. The process for installation is very straightforward. We actually have a training process that any contractor that would like to go ahead and implement this, we will do training for. We have specs to help them, and we're more than happy to help wherever we can. Finally, I mentioned I wanted to show kind of the cross section of these panels. Now, again, this is a structural solution. So as you can see from this cross section, we start off with a polypropylene honeycomb patterned core. That is strong in and of itself. And then on top of that, we'll use a polyester wool that is saturated with resin as an initial coat. We'll use our FRP material to spray on in addition. And we will then add grit on the backside, as you can see here, that in addition to the anchors allows that grout and that annular space to really adhere to both the liner and the concrete on the backside, so that the delamination potential is next to zero. And we have ended up with a liner that in and of itself has some structural capacity, which is why we can, get up into those kind of nooks and crannies and still, once that's all sealed, in addition to the anchoring, is structurally and monolithically cast to the structure. With the benefit of these products and of my company having a line product concrete manager, technical resource engineer, is that we are here to help however we can. We're more than happy to help with specification, review, and writing with engineering design. We're willing to train contractors or operators on the rehabilitation, the installation, any step of the process. And we can even be on site in those situations where it's called for. That being said, these are our permanent structural solutions. And now, with our last 10 minutes or so, I'd like to move on to any questions that you have. I think so far I've only noticed the one Q&A question that was posted that we've already gone over. But if you've had any other come up, please go ahead and, as Elena mentioned before, click on that button to raise your hand, and we'll go ahead and we can unmute you, or you can post in the Q&A or in the chat. Go ahead and do that now. While we're waiting for people to type up their many, many questions, which I'm sure are coming, I want to say again that one of our moderators is going to post a link to the survey in the chat here in a moment, which you can fill out in order to get a certification for PDHs. I want to mention that it is a fully anonymous survey. So when you go ahead and fill that out, be as open and honest as you would like to be. And once you submit that, it will take you to another page where you can download that PDH and fill that out to turn in wherever you need to. All right, looks like Mark just posted that in the chat. Thank you, Mark. Rachel asked, what is the upper temperature limit? That's an excellent question. I suppose you're asking for the FRP material, is that correct? Yes, okay. For the FRP material, upper temperature limit, off the top of my head, I'm not sure I've even gotten that question before. And that's impressive because I try to modify these presentations every time I give them to cover any new question that comes up. Elena, do you happen to know what that upper temperature limit is?
Off the top of my head, I don't remember either, but we will have to look at the spec. And Rachel, we can get back to you with the answer.
Okay. Yeah, I'm certain in the pickle jar testing and various corrosion tests that we've done on this material, we've tested for that temperature. So, Rachel, if we're in the survey, when you go to fill out that survey, if you want to make a mention of that, when we go to go through those, we'll make sure to respond to you with the answer to that, as well as anybody else that would like to ask that question in their survey. All right, Luis, how do you determine if a structure is a good candidate for reinforcement with your FRP liner, or if the structure is too far gone and should be replaced? That's an excellent question. So when we go ahead and do an analysis of the structure, we'll be able to identify what that wall thickness is. We can do that through a couple of methods, through the original design standards, the specifications, reaching out to the manufacturer, in-field measurements, things like that. Based on the existing loads that we could expect, let's say it's in a road, if it's the soil, the depth, things like that, groundwater, we can identify what the structural capacity of the remaining structure is, and we're more than happy to help out with that. yeah, we'd be able to look at that with you.
Yeah, I would like also to add to what Brendan has said. Typically, the project engineer would determine whether the structure can be rehabbed or um, replaced, needs to be replaced, and there are different techniques. Like you can hire people who can scan your manhole, and they will determine the percentage loss in the wall, and based on the scan, the engineer can determine whether it needs to be replaced or rehabbed. But with the option of when you have the PVC manhole rehabilitation, it can also add strength to the structure as well as FRP panels. So this is something to keep in mind especially if you're using high strength grout behind it.
Awesome. Thank you, Elena. All right, let's see, Jacob. Jacob asked, how is the telescoping collar or chimney attached to the underside of the slab? Do you use epoxy? There are a couple ways that we can do it. The FRP material, we have a couple of epoxy sealants that we can use to seal up, just like in the FRP panels when we go to close up those seams. So we can use that as well on that telescoping chimney to seal that to the liner that we use on the flat lid. That flat lid actually will have that liner cast into it when we manufacture the flat lid, or your local precaster, depending on where you are. And then when we send the telescoping collar, that can be sealed to that liner as well. Anything to add there, Elena?
Yeah. In general, the telescoping collar is designed to kind of be so you're able to move it to adjust like on top of the rings. If you have more rings, that you can move it up, you can move it down. It's the telescoping collar sits against the gasket, so it's a watertight. So if you want to seal it, you can seal it, or you can just rely on the gasket, which should work.
Awesome. Thanks, Elena. All right, the next question is, what kind of testing do you run on the FRP liner, ASTM, etc.? I don't know off the top of my head which ASTM standards we're adhering those to. And in fact, I mean, maybe, Elena, do you know? Let's see. I know that yeah. Are you aware which ones were, I mean, there's quite a list. And I just had it up yesterday. But I can, let me make a note. All right, George. George, I will send you an email with our testing, as well as anybody else that would like to request that when they fill out their survey. Awesome. Thank you for that question, George. All right. Then Charles asked, do you have to excavate down on the outside of the manhole for installation, or can this all be done installed entirely from inside the manhole? Seems like some of the FRP inserts had spigot joint for pipes, which would suggest in some cases you have to excavate outside. So in this case, we do not need to excavate down for the FRP or the PVC manholes. We will be able to grind down your existing flow line. In some of the photos I showed, there were pipe connectors. Those photos are actually for when we're manufacturing a new manhole base, and we're going to cast the entire thing in concrete. So when it's all cured, you will have that pipe connector just ready to fit into a new pipe when you install it in place. When you're using that FRP liner, it will be set down in that flow line and just grouted in there. But if there needs to be any removal, like let's say you had a doghouse manhole, as we call it here in Utah. I know some areas of the country don't call it that. But if you're taking an existing pipe and you are making a manhole over that, and just going to be cutting out part of that pipe, we would probably look at removing that channel of pipe just so that FRP liner can take that place. Otherwise, we could set that down in there and then just seal to the existing pipe. Hopefully that answers your question there, Charles. All right, Rachel. Oh, what a great question. I should have answered this before. I may have missed this, but is there any concern about exposure when installing new steps? So for the PVC manhole, for the FRP panels, zero concern. You can just do that normally. You can seal to it. The PVC manhole, absolutely. In fact, the PVC pipe itself has enough structural capacity that even if you weren't grouting to a structure behind it and to the structure itself, you can still use manhole steps directly on that PVC as the riser. Now, when you're using it with the grout and the existing structure, absolutely you can anchor through that PVC liner. We'll use an O-ring or gasket to make sure that at no point can those corrosive elements get through that PVC. I would typically recommend using a sealant as well in that penetration. So if that gasket or O-ring ever were to fail, it would still be protected. But yes, absolutely you can. Thank you for that question. Thank you for that second question, Rachel. All right, any other questions? Looks like we've got a couple that we owe you guys, a couple answers. So on the high temperature limit on those, and anybody that would like to see the ASTM standards, feel free to reach out through that survey. As well, I would like to point out that we have full-blown technical handbooks and specifications for these products that we're more than willing to send out to whoever would like them, would like to review them. And if you have a project that's specific that you would like to discuss the application of these products in, or the potential application, we're always open for those conversations. As you can see on this slide right here, my phone number as well as Elena's and our email addresses are on there. So please feel free to reach out anytime you have any questions. I don't see any new questions. Elena, do you have any closing thoughts or anything you'd like to say here at our finale?
Well, Brandon, you did a great job. Thank you for covering it, and I appreciate everybody's time again to learn the product. And if you have potential projects, these products are pretty unique, new to the market. So feel free to contact us. You can also find more information on our website, northwestpipe.com.
Yeah, and in closing, I would like to say that forgot to mention this earlier, but most of these products that we carry in our lined concrete arsenal are also applicable for new construction as well. So one of the benefits of the FRP panels is because it's so easy to ship and install. We've had engineers reach out around the country for saying, hey, I'm going to put in a brand new wet well, a large vault, and I'd like to preemptively, proactively line this. That's absolutely an option. And as I kind of mentioned with, the liners for new manhole bases, seemed like some of you, or maybe most of you, did not attend our previous webinar. That is posted on our Northwest Pipe YouTube channel, I believe. Mark, please correct me if I'm wrong. So please feel free to.
Yep, that's correct, Brandon.
Awesome. So yeah, please feel free to go take a look at that. We will be sending the link for this webinar recording in an email in the next few days. So you'll be able to view it, send it on to whoever you'd like to. And as well, by following that link, you can find the previous webinar's recording. So with that, thank you all so much for attending and sticking with us through this. And so much for your questions. I really appreciate the questions and the attention to detail here. So without further ado, we'll close the webinar. And again, thank you all for attending.